Hello everyone, my name is Dan the Tutor. Today we're going to be talking about multiplying square roots together. Last time we looked at adding and subtracting square roots. This time we're going to look at multiplying them. Now in my opinion, multiplying square roots is easier than adding and subtracting. And that's because, let's say I have the square root of 3 times the square root of 6. All you need to do is multiply the square roots together inside the square root. So in other words, 3 times 6 is 18. So it's root 18. And one thing that is more complicated, I'll admit, one thing that is more complicated than adding and subtracting is once you get root 18, you don't have to think, does this simplify anymore? Can we break this square root down at all? And the answer is yes, because the square root of 18 is the same thing as root 9 times root 2. That's the factors of 18. Root 9 is a perfect square. That's 3. So we get a final answer of 3 root 2 for that one. So first you multiply the numbers together, then you try and break down the square root, and that's all you do. So for instance, if I have, let's say, the square root of 12 times the square root of 5, that is going to be 12 times 5 is 60. It's going to be the square root of 60. Now if you do try and break this one down, something kind of funny happens. Root 60 breaks up into, you could even say 12 and 5. Because technically root 12 and root 5 is how it breaks up. Root 12 further breaks down to root 6 and root 2. Root 6 further breaks down to root 3 and root 2. And it looks like this root 2 and that root 2 combine. In other words, they get out of the square root. So really I have 2 root 3 times root 5, which would just be 2 root 15 as my final answer. So again, all you need to do is multiply the numbers together and then try and break apart the square root. You won't always be able to break apart the square root, but we certainly should try. Now I suppose if you want to, you can actually do the breaking down first. In other words, I see root 12 times root 5. I can try breaking it down first because root 12 is root 6 times root 2. Root 6 is root 3 times root 2. And you'll get the exact same answer. These 2's come out. 2 root 3 times root 5. You get 2 root 15. So you don't even have to multiply the numbers together necessarily. You can also just break it down. But the reason why I like the method on the left is because it's much easier for harder problems like the ones we're going to look at right now. So the other hard part of multiplying square roots together is when you want to multiply by foiling or distributing. So let's say I have the problem, the square root of 3 plus the square root of 6 times the square root of 2 minus the square root of 3. There's a lot of square roots going on here, but don't worry, we're going to get this. So if you remember foiling, first, outer, inner, last, I need to multiply every combination I see here with the parentheses. So specifically what I mean is root 3 times root 2 is going to be root 6. The next one is root 3 times negative root 3. Since they're both root 3, they get out of the square root, so it's just 3. And don't forget that minus sign, so it is minus 3. Then we do the inside, root 6 times root 2, which is plus root 12. We'll break it down later, we'll simplify it later. And then root 6 times negative root 3 would be minus root 18. And then the last step we have here is we need to break it down as much as possible. Root 12 breaks down into root 3 times root 4. Root 4 is a perfect square of 2. That just becomes 2 root 3. And then root 18 will break up into root 9 and root 2. And root 9 is a perfect square of 3. So that's going to be 3 root 2. So it looks like I have here root 6 minus 3 plus 2 root 3 minus 3 root 2. And it almost looks like we should be able to simplify this somehow, right? But the problem is you can only simplify square roots if they have the same square root. In other words, I would need another root 6, I would need another root 3, I would need another root 2 if I wanted to combine any of these terms with addition and subtraction. So in other words, even though it looks ugly, that is the final answer. I can't break it down any more than that. And that's fine. Let's look at a few more questions. For the next one here, I have the square root of 2 plus the square root of 5 quantity squared. Whenever you have quantity squared, my recommendation to you, write it like this. Root 2 plus root 5 times root 2 plus root 5. And now, again, all you need to do is FOIL it. First, outer, inner, last. So you multiply root 2 by root 2, and you'll just get 2 because the square root goes away when you multiply the same number. When I do the outer, that's going to be root 2 times root 5, so plus root 10. The inner is root 5 times root 2, so another plus root 10. And then the last, root 5 times root 5, is just going to be plus 5, because whenever it's a match, it doesn't get a square root. So now I need to combine like terms. Looks like this 2 and this 5 combine to be 7, and since these square roots are the same, I can add them. But remember how I add square roots, really? I add the coefficients, and there's an invisible 1 in front of both of those root 10s. So in other words, root 10 plus root 10 is 2 root 10. And that's as much as we can simplify that. So that's going to do it for that problem. Here's the next one we have. This one's going to be even harder than the last. 2 root 8 plus root 3 times root 3 plus 2 root 6. So for this one, we have the added challenge of coefficients in front of our square roots. And I'll tell you what to do for that. But again, the strategy is still FOIL. So the first thing we do is 2 root 8 times root 3. Whenever you multiply combinations of square roots and whole numbers, remember this. You can only multiply the square roots together, and you can only multiply the whole numbers together. So what I'm saying is, when you have 2 root 8 times root 3, you only multiply the root 8 and the root 3 together. That 2 just stays the same. Don't touch it. Root 8 times root 3 is root 24, and that's going to do it for our first FOIL. For the outer, I've got 2 root 8 times 2 root 6. Remember what I said earlier, I can only multiply the square roots together, and I can only multiply the whole numbers together. So what I'm saying is 2 times 2 is 4, and root 8 times root 6 is square root of 48. And so it's going to be 4 root 48. And like I said before, I'll simplify it later, but this is good for right now. Next is the square root of 3 times the square root of 3. They just add together to make 3 because they're the same square root, so it just loses the square root. And then the last one is root 3 times 2 root 6. Again, that 2 doesn't combine with anything, you just write 2. And root 3 times root 6 is root 18. Now we need to start simplifying this by breaking apart our square roots. Root 24 is equal to root 6 times root 4. We know the square root of 4 is a perfect square too. And root 6 doesn't simplify because its factors is 3 and 2, and that won't simplify any more than that. So remember that this 2 right here needs to multiply with that 2 to give us 4, and then the root 6 is still under the square root. So that's what the first one simplifies to. The second one, square root of 48, is equal to root 6 times root 8. Root 6 breaks down into root 3 and root 2. Root 8 breaks down to root 4 and root 2. Root 4 is a perfect square at 2. These two root 2's combine together to just make a 2. So really what I've got here, I've got this 4 still from the first outside the square root. So 4 times 2 times 2. And then there's still a square root of 3 still inside the square root. That's going to simplify to 16 root 3, because 4 times 2 times 2 is 16. And then root 3. We're not going to touch the plus 3. And so then the last one we have here is 2 root 18. Square root of 18 is root 9 times root 2. Square root of 9 is 3. And 3 times 2 is 6. So that will become 6 root 2. So now let me write everything out very nice and neatly. I've got 4 root 6 plus 16 root 3 plus 3. Can't forget about that plus 3 right there. And then plus 6 root 2. And like we said before, we can only add square roots if they have the same square root. None of these square roots are the same. So this is our final answer here. That's how we do it. And now let's look at one more. This last one will be interesting. I've got the square root of 10 plus 4 root 8 times the square root of 10 minus 4 root 8. This, by the way, has a special name. It's called the conjugate. The conjugate is whenever you have two factors with a square root in them, and the first term is plus and the second term is minus. And we're going to see that we really like it when we multiply by the conjugate. You're really going to like this problem, and you'll see why at the end. So again, the strategy stays the same. We FOIL. Root 10 times root 10, that's just going to be 10. It loses the square root. Next is root 10 times negative 4 root 8. Remember, I only multiply the square roots together, so root 10 times root 8 is root 80, and there's still the minus 4 out in front, so minus 4 root 80. Next we do the inside, 4 root 8 times root 10. Again, we only multiply the square roots together, so that's going to be plus 4 times root 80, because 8 times 10 is 80. And then the last one, 4 root 8 times negative 4 root 8. This one you have to be careful with, because you multiply the whole numbers together. 4 times 4 is 16. It will be minus 16, because that negative sign right there. And then root 8 times root 8 will be just 8. No square root, because it loses the square root. And now we need to simplify this. So the 10 doesn't change. Negative 4 root 80 plus 4 root 80, hey, those just cancel out. They're exactly opposites of each other. And that's why I said you'd like this problem. That always happens when you multiply by the conjugate. The square root terms will literally cancel out with each other, and now we don't have any more square roots. The last hard thing we need to do is 16 times 8, which is 80 plus 48, so 128. So it's going to be 10 minus 128, and that's going to be a final answer of negative 118. And there is our final answer for that one. Wasn't that fun? And so that's all the examples I have for us today. Thank you all for watching. If you do have any questions, please post them in the comments below. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.